Hey, welcome everyone to this week's Code in Cask. We're going to be going over some interesting stuff this week. First, we're going to talk a little bit about um, the Bybit cryptocurrency attack that happened from Lazarus Group last week, or the week before. And then, because a few more details have come out about potentially how they did it. Then we'll talk a little bit about kind of ransomware stuff, and then we'll spend the rest of the time working on some ransomware code, the simulation code that I've been building. We'll talk a little bit about that. Basically, ransomware is at its core is really not all that complicated. It's just an encryption algorithm that you have the ability to control remotely. So we already have C2s like Empire, and we already have code examples for writing stuff to encrypt files because that's a normal thing. So you combine those two and you get a ransomware. So we'll talk a little bit more about that as we go on. So first things first, how's everyone doing this week? Anyone got any interesting upcoming weekend plans going on? So, yeah. Yeah, so let's see. The Bybit exploit happened a little over a week ago. Like 2 weeks, just under 2 weeks ago. But more details have been coming out about it. In case you haven't seen information on the Bybit attack, basically North Korea stole $1.5 billion in crypto. It's an interesting attack from a technology standpoint, just because if you go read some of the reports, there's still, with it only having been a week and a half ago, there still isn't a lot of information out yet on what exactly they did, like how the initial compromise happened or anything like that. But there has been some reporting on just kind of the timeline of events, and then they do have like a key point on what happened on how they actually stole the crypto. It just hasn't been reported yet how they initially got into the safe UI thing that we'll talk about. Uh, oh, nice! Congrats, Simbader. That's very cool. You got your sins thing. Your sans, not sins. Your username threw me off. So basically what happened is within the span of about 2.5 hours, they stole, not only did they steal the money, but they had already split it up across multiple transactions and started laundering the coins so that you couldn't trace where all the money went. So it was very, very quick when it happened. But what they ended up compromising with this safe UI thing, they injected a JavaScript payload that allowed them to modify the like smart contracts that were going in real time. So they ended up displaying like it's kind of how some people have talked about potentially how some supply chain attacks have occurred as well, where even though stuff's going through code review, if someone's low enough in your like CI/CD pipeline, they can basically start the system, causing the system to display one thing to you while actually sending a different thing elsewhere. And that's basically what they did here. They modified it in real time so that when the security team was approving and like signing the transactions to move money from Bybit's cold wallet over to the hot wallet, it injected malicious code at the time of signing and reported the transaction as having happened correctly, which bought them a little bit of time on how they could go about doing that kind of stuff. Certainly a very advanced attack. And this is kind of where Lazarus Group has moved. So Lazarus Group is obviously most famous for a lot of their ransomware attacks. They were the ones that made WannaCry and the Sony hack and a couple other things that involved like very high profile ransomware. They've since kind of evolved to be a little more focused on this cryptocurrency stealing train. So this has been their main target for about a year and a half now, of just targeting crypto exchanges and sorry about that. My headset turned off for a second. Um, they So they've been focusing on stealing cryptocurrency. It's just easier for them to get payments. It's easier for them to steal huge amounts of money quickly and then to launder it quickly, because they don't have to stay in contact with the victim. But that doesn't mean that ransomware is no longer relevant for us. Although interesting, if I remember correctly, I believe the number of ransomware attacks actually dropped for the first time last year. Um, it was a slight decrease from where they had been. But that doesn't mean that there aren't high profile attacks happening. Let me find. We just had this one last month, which was Tata Technologies got targeted and hit by a big ransomware. And yesterday they had 1.2, I guess it was 2 days ago, they had 1.2 terabytes or 1.4 terabytes of their data put out onto the dark web for sale. If you're not familiar with Tata, they're a huge Indian conglomerate. They're like the largest company in India. They own like everything. They're like India's Amazon. They own everything from car manufacturing. Actually, they're probably even more ubiquitous than Amazon is in the US. But they do everything from car manufacturing to like delivery services to they own everything in India. And so they just got hit by a big ransomware attack in February. They were down for a couple of I think they're only down for a couple of hours, but they did have a bunch of data stolen. And so we're still seeing lots of ransomware attacks. There was also the Secure Group ransomware that just hit. Let me pull up that one. Oh, yeah, this was an interesting one where they were running the ransomware off of a webcam to initiate the attack. And so this is the Akira Group. So they attempted to deploy like encryptors on Windows, which were blocked by the victim's EDR solution. So then they went to the webcam and started deploying stuff that way. And so it was pretty interesting. But again, once again, they were using RDP to move around the network. So regardless of how old that technique is, RDP is still super common. Yeah, so their victim quarantined it, essentially blocking the attack, which is kind of interesting. So they went through alternative pathways. Yes, they found a webcam and fingerprint scanner. Since it ran on Linux, since it went to since it's on Linux, they didn't have an EDR installed. So this is like another thing that's really interesting. Even with red teams, a lot of the people I know have started kind of leaving Windows boxes alone as much as possible because it's gotten so hard to operate on Windows that they just look for Linux devices on the network and run all of their attacks out of there. And we're starting to see threat actors make that decision as too. And then what they did was they started remotely encrypting the share drive. So this gets to another thing that like we like to harp on a bit in some of our classes when we teach, is that like domain admin is not necessarily the most important thing for a red team to achieve. It's really cool. You get to wave the I1 banner when you hit domain admin. But a lot of times you don't need elevated permissions to wreak havoc on a customer network. So all they needed was a device that allowed them to have a connection to the share drive. that they wanted to target, where all the sensitive data was stored, and then run the ransomware that started remotely encrypting drives, and they were able to kind of wreak havoc that way. So very interesting. Kind of start off to our discussion on ransomware. Let me pull up the window just to make sure I didn't miss any chat questions. Yeah. Oh, someone just asked what we're up to. We are doing. We're talking about ransomware attacks and what's been going on recently uh, in the world of ransomware. Because for the first time last year, ransomware was like ransomware attacks actually went down a little bit. Now, one of the interesting things about ransomware and what is considered quote unquote ransomware is you'll see they've started calling it like double extortion, which was the attackers would encrypt all of the devices um, on a device or on a network, and then charge money to unencrypt the network. Then they would also come back again and say, "Okay, we also stole all your data, and if you don't pay us, we're going to release the data that we stole. So you need to pay us again." There's actually been a few ransomware groups that have actually moved to like quote unquote uh, encryptionless ransomware, which is basically they just steal the information and then threaten to release it unless they get paid, which isn't really ransomware. It's kind of more traditional like espionage. Uh, but it's the groups that ran ransomware, so they call them that. So it's kind of a little silly term. Um, but yeah, the Secure Group one was cool because they just needed remote access. Yeah, so they're able to encrypt files across the victim's network. Because like this is like another interesting thing when you guys are getting ready to do red team assessments to think about is um, they had access to that share drive. They may also have had permissions from what it sounded like, to access all the other remote computers, like the workstations. So like they might be able to have go to like the admin shares and that kind of stuff. Once you get to some of the admin shares, they can get to certain parts um, of the drives as well. And so they could start sending tasks. They could potentially push out stuff through like um, PS remoting and that kind of stuff to encrypt more files. And so they may have infected like a large portion of the network. They just had to get off the EDR that prevented like the initial boot up of their machine, because a lot of the stuff that's in like modern red teaming requires either a computer with local admin credentials on it where you've disabled the EDR, which we don't typically do as red teams because that involves kernel injection stuff. Like you're bringing your own vulnerable driver, and that has a high chance of causing a crash uh, on a computer. And as professional red teamers, the last thing we want is someone screaming at us that they had an employee that lost a report that they've been working on for 3 days because we corrupted the memory on their computer and it crashed and erased it without saving it. Ransomware people don't care if they do that. Or you go to a Linux box where there's no EDR, and then you can start running up all your stuff, because then you can start doing your resource-based constrained delegation attacks, like all that kind of stuff to elevate privileges and access remote machines. So, oh, I'm happy if you have a specific question. I am happy to go like slow it down a little bit and talk specifically on anything. I'm just kind of hitting some high level stuff because we're gonna start diving down into some code in a second. But if you have any specific questions, I'm happy to talk about that. Always more questions and interaction always makes things more interesting for the stream. So, but but before we start doing that, I'm gonna pour myself some whiskey since we're doing code and cask. Is anyone else drinking anything interesting today? Oh, uh-oh. I have to. Top broke on the bottle. Not ideal. I am drinking a Willet Family Estate bourbon. So if you're in the U.S., you may have seen Willet before with a. Let's see if you guys can see that. Yeah. So this has a purple top on it. You may have seen the green tops before. That's their family estate rye, which is like a 4-year-old rye. It's one of my favorite ryes ever. But that's pretty easy to get. Like, it's everywhere. The purple are their bourbon, and if you're not familiar with the difference, bourbon has to be at least 51% corn. Rye has to be 51% rye in the mash bill. But it doesn't matter too much. But the purple tops are like a lot less common. They've been starting to sell more of them because Willet started making their own whiskey. They were sourcing a lot of it for a long time, and then about 8 years ago, 10 years ago, they started making their own distillate, and now that all that has aged, they're starting to sell more of the purple top stuff, so it's getting like much easier to find. But it's like one of my favorite whiskeys of all time, so cheers. The only downside to it is that it is a little on the high alcohol. A little high on the alcohol percentage. Oh, did we get any whiskey while we were at Hack Redcon? We did. We went to, I'm totally blanking on the name of the store, which is a bummer. But we found a store that had like super cheap prices, which is really unusual. We were walking down the street to go to dinner, Coin and I were, and like just saw this like hole in the wall place, like in a kind of a sketchy neighborhood, and we walked in and they had like an amazing whiskey list for like super reasonable pricing. And so we did drink a lot of whiskey while we were at Hack Redcon. We went back there like 2 or 3 times because it was only like a 10-minute walk from the hotel. But they did not have purple top there. They had some other really cool stuff that I have not had before, but they did not have purple top. Actually, we're gonna go to, say, using our Kali computer to start with. We're gonna go over to our Windows computer. But yeah, if you go to Hack Redcon next year, the trick is to not buy whiskey at the hotel, because the bar prices at the hotel they were at were like crazy. So you can kind of see that we already, that I had already ran some testing on this box. So the box leaves like a ransom note on it. Let's see, is my ransom note encrypted? It might have been encrypted. Let's see. I might have double, yeah. So I wrote a ransomware module in IronPython that we'll be talking about. But basically, since it's a ransomware simulator, it drops the first thing it does on the box, or before it even starts encrypting, is it generates the encryption key and writes it to the box as an excluded file, and also writes it on the server so that I have the key. So you know that the files can be decrypted. But it does actually encrypt files, which so normally if I'm deploying like an actual ransomware module on a customer network, I don't do it to a actual computer that is being used for like operations. Nowadays, most places are running a hybrid system, or at the very least have like computers that are like being pixie booted, so you can easily stand up a computer with a clean image on it that's not being used by anyone, and I'll have them give me a target device that I can go run like an actual full-on ransomware encryption on, so that they can test their detections to see like if their system picks up on the encryption and that kind of stuff. So but you always want to test to make sure that you're actually, producing the key and have a recoverable key and everything. So let's jump into our code now. So first things first. Has anyone on the stream ever written their own ransomware module or tool or whatever for a customer before? Did they talk about ransomware at all in that SANS course for your SANS Red Team certification? They don't at all. Interesting. That's kind of curious. I figured they would at least talk on it. Oh, and then Denied Firewall just asked a question. So if you're trying to just get started, then and you're in high school, then yeah, if you just start posting like Python scripts that you've written, any kind of project, go and modify a project, fork a project to make some minor changes to it. That's all good ways of building your portfolio to show like employers what you're looking at and what you're capable of, and like that you're self-motivated. So that's always like a good thing to go do. Hold on one second. I'm trying to find my notes on the. I think this is the one I want. Nope. That's my turtle in it. Ah, there we go. I found it. Sorry, guys. Okay. So let me pull up I believe I have Notepad++ on here. So we'll just save this as. I will zoom in a second so it's readable for you guys. I'm just gonna name it ransom test, but I want you guys to be able to follow along. So. I thought I was gonna save. Okay. Okay. So in order to do encryption, if you've never written anything with encryption before, the first thing we have to do, or there's really like kind of 4 steps to what we're doing. We have to generate a key. We have to generate an initialization vector. So IVs help you make it so that your encryption like is different every time, so that's harder to crack. We have to pad the data to make sure that our block size is the correct one, because when we're doing like AES encryption, it's blocks of like 256 bytes or bits. And then we have to actually apply the encryption. So it's not very hard. It's you'll be surprised at how short the code is, but it is like a thing we need to do. So if you want to follow along for Python, we have kind of like 5 libraries that we need. Actually, argparse is just, we're going to use this to make it into a module for Empire at the end. You actually don't need this to do like any encryption. This is their crypto library. We're going to use random because if you just use, I'm totally blanking on what the other Python function is. But there's another Python function that's like Python just dot random, and so like from the crypto random library, and it's all of these are kind of like pseudo random anyway, but the random from the crypto library is much more effective. If you're not familiar, if you use like just standard random, like quote unquote random functions from computers, maybe they're a little better now, but they used to all be like seeded the exact same. So like if you had two computers from Dell and like you went and used like the Excel random number generator, like it would produce the same output like on the computers because the random wasn't actually random. They just like seeded it before they went out, and so they all had the same quote unquote random number generator. So that is like a major weakness in some of these libraries. So you want to make sure that you're using the proper library. He made a lightweight Wireshark copy. That's pretty cool. I have not done that. First thing, so we imported that. The next thing we need to do is create a padding. So we're gonna do this. So padding's really simple. They actually came up with a really clever. So I put a note in here that this is PKCS7 padding. So basically, they came up with a really clever way of denoting how, like, so we have to pad everything to the same block size, right? So whether that's 256 or 10 bits or whatever we're doing. If we have to add bits to make everything the same size, when we go to unencrypt it, how do we know how many bits were added? Is kind of like the quintessential problem. And so how that problem was solved is pretty straightforward. Basically, you see how much smaller your data is than the block size. Typically, that's going to be, well, it's the remainder of the block size, really, which is going to tell us the pad length of how long we need, of what we need. And typically, it's like less than 10 bytes or bits. I always get confused. Bytes. How many bytes? Usually it's like 10, 8 or something like that. So instead of trying to come up with some clever calculation, we can just make the byte value that we're padding with the number of bytes that we added. So if we're adding 8 bytes, then the last 8 bytes are just going to be 8. They're both all 8 bytes will just be the number 8, and so on. So like if we're gonna do 10, that's just the number 10. As long, obviously it has to fit in a single byte, but that gives you the kind of the gist of how padding works. And so you just look at the last byte on the block, and that will tell you how much padding was added. So we're going to pad the data is the first function that we have to build. Like I said, it's just the remainder of the block size. So you do block size minus the length of your data passed in, and then do a mod function on the block size to get your pad length. Then we convert our pad length to a byte array of pad length, and multiply that by the value of pad length. Like I said, it's just, so if it's 8 bytes, then every byte in the byte array is 8. So makes it super easy. That happened last stream too, but it hasn't happened in between the streams. My headset just randomly shut off on me. At least I caught it this time, and I wasn't talking to you guys for 10 minutes without you guys being able to hear me. So we'll go on to the next part now, which is just going to be to unpad the data. So unpadding the data is easy. Like I said, you just check the last byte of the data, which tells you the number of padded bytes, and then we grab we just do array splicing, and we return the array minus the last number, minus the value of whatever the last byte was. Super simple, but now you've learned how to pad data for encryption. So our encryption function is slightly more complicated, but still pretty straightforward. Especially since we get to use the AES encryption library, we don't have to implement everything ourselves. So we're going to encrypt the file. Like I said, we're getting a new random key. The key needs to be 32 bits. We're going to base 64 encode the key just so that it's readable and easy to replicate. So it's the whole that's this right here is the entirety of the reason, and for being able to pass when we turn this not just into an encryption algorithm but into or function and turn it into our weaponized module for Empire. It's we'll use it for decoding the key, but this is the only reason we need this base 64. The base 64 is not used for the actual encryption. It's just to make the key more manageable for passing around while we're doing operations. So our IV is going to be our random.new with our block size, and so we'll get whatever we passed in as the block size, which where did I forgot. Our block size is going to be 16. I missed some data on here. So our block size is 16. And since we defined block size up here, it's just accessible to everything. So it'll work like that. So all we're doing once we do that is right now we're going to pass it in an input file. It'll open the file, read all the data in the file, and then close the file. It will then use our AES key mode with our initialization vector to encrypt the data. We'll then, or to create our cipher for our AES object for our encryption. We then pad the data before we pass it into our AES object to encrypt the data. We then just take our file name and we just add a .crypt to it to indicate that it has been encrypted. I use this .crypt. Basically, this can be anything arbitrary. It's good when you're doing red team testing to kind of keep an eye on this extension, because there are a number of EDRs and AVs that claim to detect encryption ransomware behavior live, but they're not actually doing a good job of detecting behavior. They're just monitoring for the file extension to appear. So if you think that's happening, or you just want to make sure it's not, you can go periodically change your file extension to whatever you want it to be. It doesn't matter. It's just a way of tracking which files you've encrypted and being able to find them for unencryption when you are ready for that. So we then open our out file. We write in our data, and we go ahead and write in our encrypted data with our IV, and then we close the file. So this writes our file to disk with the .crypt extension, and everything's been encrypted. We then need to be able to, if we want to be a functional quote unquote ransomware, we also need to be able to decrypt our files, which are basically the same thing. We just pass in the base 64 encoded key. Just have to generate a key. And you'll see when we go to weaponize this that we will actually remove this, and the key will be passed in so that we actually can consistently use the key. But because right now, if you notice, this does not write the key. Oh no, it does write out the key right here. Yeah. So it writes out the key right here, but it doesn't write it in a note or anything. And it doesn't return the key. So if you don't see this when you run the code, you're kind of SOL for being able to unencrypt it. So we will make that more robust when we go to make this into a module. Here, I'll zoom in a little more for you guys just to make sure. But this is the same thing in reverse. We open the file, we read the data out of it. We get the encrypted data. We close the file. Here we get our key from the base64 encoding. We create a new AES object. The IV is always the first 16 bytes of the code. We then decrypt it. We like unpad the data is actually like we call it like, oh, this is the padded data. Sorry, not pad. So we decrypt it. The data is still padded. We use our unpad function up here to get the data, and then we remove that, and then we can write the file out, and then it's all good. Very simple, straightforward. So now for our final part of our script just for testing, we're going to add a little functionality to make this like a functional Python script. So when we call the script, it'll read the arguments off the line. It'll input file as the initial argument. And then we have like an optional argument that's like our attack K. If there's no key argument, then it encrypts the file. If there's a key argument, it decrypts the file. So now just to go, we'll go ahead and save this, and we're just going to create kind of a new test file. So we'll just leave this in here so that we know that the file has either been encrypted or not. So we'll save this as okay. So we'll leave that as is. Now we're just going to go start up our PowerShell. And technically this works in IronPython or PowerShell or Python. We're just going to use Python for this to run it. So cd into our desktop. Except for some reason my tab complete has not worked. Wait, why don't I have a desktop? That's weird. There's no desktop folder. Uh-oh. Can't type. How is that possible? There's not a desktop. This doesn't make any sense. Hold on. We're in the desktop. How is this? Oh, the desktop's in the OneDrive? That's weird. I didn't know that was a thing. Huh, yep, it's there. That's weird. Well, learned something new today. So if we run this, it should throw an error. Is IPY on here? Oh. I guess we'll just use IronPython. I had Python installed on this box too. Okay, let's just install Python on this real quick. These window test like developer boxes keep getting weirder and weirder. Okay, we're installed. So now, if we close this, okay, there we go. No module named crypto. Okay, we might have to go run this on a different box. I don't know why might just run it on my bare metal here. Okay, give me 1 second. Yeah. There we go. We should be able to drag and drop this over. Okay, so hopefully this works and we don't keep running into shenanigans. Okay, what is going on? Hold on, let me go check my other code that I know works. Okay, well, here, we'll just do this. I was gonna jump to I was gonna demo it with Python, then we we're gonna move to Iron Python. We're just gonna turn this into Iron Python because I know that code works. So we will just jump over to that real quick. The only difference, yeah, here, I will show you. It does get a little weirder, but we'll go ahead and write the code. And this code has lots of information in it, so we'll just walk through it real quick. I did not think I would need to double check my Python code. But okay, so there's a couple of different things when doing Iron Python. You have to add a COR.add reference to your code in here to get our system.security. So we're going to be using we're going to be using .NET types for all of this. instead of using standard Python types, it just makes the stuff a little easier. So like you'll see, note to convert this Python bytes to a .NET array, or create our random IV. Yeah, we don't need this comment. So the encryption gets a little different because we use this with CryptoStream thing to do like a memory stream, AES dot create encryptor, CryptoStream mode dot read as CryptoStream. It's the same thing that we were doing before with that, like creating an AES thing. It's just a little more convoluted because we're using the .NET through Python. So call looks a little more complicated, but it's really just the same thing. So you have to make sure that you're using a .NET memory stream instead of a bytes IO object. Otherwise, they won't work together. The bytes IO object is what Python tries to automatically convert it to. So that's why we have this like memory to stream function that just forces it to be something different. Then we encrypt the data, same type of thing. Very straightforward. We then write the encrypted file. Same code, just looks slightly different because it's kind of like a C#-ish type of code. And then in this one, since I already built this to be like an actual ransomware module, it also removes the original file once it was written. So it doesn't exist anymore. We then have our base64 decode because we pass in a file key. We have our AES stuff that does all our things. We decrypt it just like the other way. There's an added function in here for the dir and for directory encryption, so it'll also encrypt directories. So basically, it just becomes recursive. So the only function is instead of encrypting it, difference is instead of encrypting a single directory, it directs it does it recursively. And same here, recursive decryption. So you have all these options that makes the code a little more useful. And we'll add some stuff in, but that's pretty much how the Iron Ransom where Python stuff works. But let's see. It's annoying me that my Python code's not working. Let me double check what I need to do here. I'll just quickly ask ChatGPT what this means. But does anyone have any questions so far? Oh, that's what it is. I need to install PyCryptoDome. I just installed the wrong library. That's what it was. Okay, so now our ransom test should... No? Can we make this cryptodome.cipher? I ran this code earlier. I don't know why it's not working. I don't think this. I think ChatGPT is lying to me, but we'll try this. Okay, what is going on here? I'm not sure what the issue is, but I will figure it out and let you guys know. Hold on. Give me 30 seconds. Okay, Pi Crypto is broken, but I knew that. I don't really care. Apparently, you're okay. Well, apparently, I'm not crazy. Apparently, your install can become corrupted. So we're gonna try uninstalling Pi Crypto. But I knew that Pi Crypto is not like cryptographically sound anymore. So we had a thing called crypto. So oh wait, the scripts crypto.exe are installed in, which is not on path. Oh, hold on. Okay, we'll try this one more time, but we might need to fix the path. Might be the issue. We're having a path issue. That's what it is. Why can't anything ever just work the first time? The demo gods are not in my favor today. No, whoops. Okay, we have a ransom.py on here. Let's see if that one. Yeah, okay. Oh. Padding's invalid. Okay, so let's go look at our ransom. We might just have to end here. I apologize for the demo fail today, guys. I'm not sure what our issue is. Okay, so let's try. Yeah, so it failed because I had it hard coded in here. We're not going to give it a key. We'll put our files in a test directory and see if this works. You can see this stuff's already encrypted, so we'll just leave the fake ransom note in here. We'll let it encrypt it one more time. So we'll try running this again. It shouldn't be running decrypt. Oh, we didn't save it, that's why. Okay. Come on. This should have worked. Feel it. Okay, what is modifier code? Oh, whoops, that's why. There we go. Okay, so our encryption ran that time. We at least got one successful encryption. So you can see now the ransomware node is encrypted. It's unreadable. And same here. It's been encrypted twice, so we'll go ahead and end there. I apologize for the technical difficulties. I'm not sure why my Python code is no longer working on the box that I tested everything on. But technical difficulties, can't always win with demigods. But thanks everyone for coming this week. I'll see you again next week. Actually, we may be off next week because I'll be traveling. But thanks for coming. Have a good one. Bye.